In today's episode of the IoT Show, we have Krishna from the Azure Stream Analytics team who comes to talk to us about machine learning anomaly detection into Stream Analytics at the edge with a nice demo on the Raspberry Pi. Hi everyone, this is the IoT Show. Thanks for watching. I'm Olivier, your host. We have Krishna from the Azure Stream Analytics team with us, and we're going to talk about machine learning on Stream Analytics. Krishna, thanks for joining the show.
Thank you, Olivier. I've always wanted to be here, so finally I'm here.
There you go, you arrived. You will need a stick. Oh, you have the IoT Show stick.
I do.
Yeah. You'll have more, don't worry.
Okay.
So, Krishna, first of all, who are you? What is the team you're working for doing?
Awesome. So, I'm a principal PM on the Azure Stream Analytics team, and our team builds Azure Stream Analytics, of course, and we have customers using Azure Stream Analytics in many different ways.
Okay.
And one of our biggest set of customers are really coming from the IoT side. That's why we work very closely with you and the other members on the IoT engineering team.
Okay. I think it'd be interesting to look closer into, Azure Stream Analytics. People certainly know it, but I'd be interested if you can actually summarize real quick, what are the key advantages of Stream Analytics? What is it that IoT developers and people building these IoT applications can benefit from by using Stream Analytics? Because I realize that very often people are underutilizing it. It's like a super powerful tool, but people don't really realize what it can do.
Yeah. So I would be more than happy to take that question one piece at a time.
Yeah.
So the first and foremost, why customers tell us they really love Stream Analytics is all about ease of getting started. Mm-hmm. They can start with a very simple SQL-like language. You don't need to learn a new complex language in order to define and declare very powerful analytics. Yep. But once you master the art of interacting with the engine using your SQL language, we also provide extensibility with other languages like JavaScript and C#. Let's say you have very complex mathematical functions, typically not expressible very easily in a SQL-like language. Yeah. You can define that using your math libraries in C# and just make a UDF call to that function from Stream Analytics SQL language.
Interesting, yeah.
We also provide sub-millisecond and millisecond latencies. Once the data is in the cloud, within a millisecond or two, we can actually process the data, analyze the data, and give you the response back. Mm-hmm. And in the last 7 or 8 months, we've been talking about the whole concept of IoT Edge. We are now a service that is generally available both in cloud as well as on IoT Edge. Yep. So for a lot of these scenarios where customers want to run their service in a disconnected or offline mode from the cloud, we can actually run these real-time analytics on the device itself. Yep. We are one of the cheapest services in the market. Customers love it. You can just get started at just 11 cents an hour and scale up from that point onwards. But the real promise and the real power of Stream Analytics is all about the built-in analytics and the built-in capabilities that are not probably available in other services that are around. For example, there are built-in geospatial analytics. Okay. Right? So with simple function calls, you can actually define geofences. You can manage thousands of assets across hundreds of geofences, create alerts when a particular asset leaves a geofence, enters a geofence, when the distance between multiple assets is increasing or decreasing beyond a particular threshold. Then of late, we have also been adding built-in machine learning based capabilities in Stream Analytics, which we will talk about more.
Talk more about,
and as a service, customers want auditability, right? So what we promise is no data loss. Right?
Okay.
Once your data lands,
nothing lost. Right?
Nothing lost.
Okay.
Once your data lands in IoT Hub, we ensure that every event is processed. Right? Okay. We promise what we call repeatability. Given a particular event and a particular set of algorithms, you will always get the same result whether you are running that analytics live or replaying that data at a later time to find out why a particular decision was taken. Okay. We are once only processing service. Right? So we process every event only once. Okay. And that is really important, especially for scenarios where you have to maintain your ledgers and financial transactions and things like that. So all these things together make Stream Analytics a very unique and powerful solutions for our customers to use.
Yes, definitely does. Can you actually drive us a little bit into what kind of architectures people are building using Stream Analytics, especially in the context of IoT application? What are the various services they put together, functionalities, in this kind of like, I know you have a diagram coming up, so I'm curious to know a bit more about that.
Okay. So this is a canonical architecture of a real-time analytics hot path pipeline. On the left-hand side of the screen, you have devices that are continuously sending data into the cloud, and we pick up the data from IoT Hub, right? You can analyze and join multiple fast-moving streams of data. We are not just a signal processing solution. We are actually a complete end-to-end complex event processing solution, meaning you can join multiple fast-moving streams of data, and you can join the streams of data with what we call reference data. For example, let's say you are continuously monitoring telemetry from a sensor, and you don't want to send all the time where is that sensor located, for example, when was it last calibrated, because that data doesn't change very often. So just before that event or the transaction hits the stream processing engine for analysis, you can join that reference data with the streaming data so that you get a more complete analytics picture of what is happening in your environment. And once you process the data, you can store the data in Azure repositories, whether it is Cosmos DB, whether it is SQL DB, SQL Data Warehouse, Azure Data Lake, you name it. We see a lot of customers also do real-time dashboarding with Power BI. You will see that in the demo. We work very closely with the Power BI team to enable what we call push APIs, so that you can get a very dynamic view of what is happening in your ambient environment. And finally, this I would say is the most important thing. You can kick off workflows downstream by integrating with services like Azure Functions, Service Bus Topics, Service Bus Queues, because once a customer finds an anomaly or something that they need to take an action on, they need to trigger some kind of workflow downstream. And that is possible through integration with services like Azure Functions. One thing that I want to talk about is our integration with Azure Machine Learning. For a while, what we had in the service is integration with the endpoint of Azure Machine Learning service.
So basically, from your query, you would actually call an API. That would be actually executing somewhere else. So customers train their models and they build their models in Azure Machine Learning service, and then there is like an interaction between these two services. We call the REST API endpoint of the service so that we do continuous scoring. But as you know, interaction between different services induces some latency, and more importantly, for a lot of customers, getting a data scientist on board is expensive. So we actually looked at what is our customers doing. We were getting feedback about the cost aspect of it. And we saw that about 60-65% of the customers who were running machine learning algorithms in the context of stream analytics were doing some kind of anomaly detection. So that was one of the most common scenario, basically.
So we thought, how can we actually help these customers more? And we decided to work with Microsoft Research. And we got their algorithms. And we just baked them into the code base of Stream Analytics, so that with just simple function calls, you can abstract the entire complexity associated with training and building your own models and all of that.
So you're saying it's part of Stream Analytics, basically. It's part of the code of Stream Analytics itself. So it's going to be also something you can package and send to the edge. And that's why you have a Raspberry Pi here, is because you basically are packaging Stream Analytics with machine learning anomaly detection in the box. I'm not burning the demo, but I'm excited about that, definitely.
So let me talk a little bit about this particular feature. Like you mentioned, this feature, built-in machine learning-based anomaly detection, is available both in the cloud and on the edge at this point. And we can detect anomalies, both spikes and dips, which are more like momentary anomalies, but also we can detect things like slow positive trends, slow negative trends, or bi-level changes. For example, let's say you are monitoring a VM for memory leak. It is not an anomaly that happens momentarily. It slowly sort of creeps upon you. Right? So with a naked eye, you may not be able to detect that it is an anomaly, but with the algorithms, you can.
Makes sense.
And these models are not pre-trained models. So these models learn from the data that they are looking at.
Okay, so that means, well, which makes sense when you think, especially in IoT, where two devices might not be the same. Like they are in different contexts, and their environment is different, temperature, pressure, whatever, and they might not actually act or have the exact same behavior, even though they're the same device, right?
Exactly.
Yeah, interesting.
Yeah.
Okay.
Yeah. So we did not want to come to the table with these algorithms with a notion that all data streams follow a particular distribution. So we wanted to learn from the individual telemetry distribution and then detect if something is an anomaly or not.
Okay. It seems something that's kind of heavy, right, in terms of like storage requirements and processing requirements. Is that the case, or are you actually guys optimizing everything, especially for the edge, when I think about these devices?
Yeah, I mean, there is no hard and fast answer here. It all depends on the throughput of data that you are processing, right?
Fair enough.
And also how complex the other pieces of analytics surrounding your machine learning algorithm is. But the good thing is Stream Analytics can scale linearly and scale up and scale out in the cloud. And of course, on the edge, you need to have an edge device that is compatible with the data that you are processing.
You need to put as much, oomph
exactly
as needed, right?
Yeah.
Okay, makes sense. Okay.
And let me quickly go through the function signature. Let's take the example of spike and dip. We have two functions essentially, one for momentary anomalies that occur, and the other is for slow trends. Let's just look at the function signature for the spike and dip. The first argument there is scalar expression. It is nothing but the attribute on which you want to run your anomaly detection, be it temperature, humidity, pressure, whatever. Confidence. This is very important because this sets the sensitivity of the model. Okay. You can tell the model to flag a particular event score as an anomaly only if it is at least X% confident that it is an anomaly or not. Right? And the next argument is history size. So this is where you are telling the model to learn from at least n number of data points that it is seeing before it starts
triggering anything.
Scoring. Right? So these are the key function signature arguments that you will pass. The next one, the partition by clause, is very powerful. Let me talk to you about how it works. Let's say using the same query, you are managing 1,000 different devices. And each device might be different, right? One sensor might be sending temperature, one sending humidity, etc. So with this partition by clause, what happens is behind the scenes, we will spin up 1,000 different models with the same function signatures, each model working on a particular telemetry stream and then triggering anomaly for that particular individual sensor.
Was just like one parameter in that function call, basically.
That's really the power of Stream Analytics, like you were talking initially about it. We made it very easy for customers to actually do these kind of things with a single query and with very few resources.
Okay, well that looks all good. I might want to see some of that in action, right?
Awesome.
So you have a demo?
I have a demo.
Let's jump into the demo.
Awesome. So what I have here is a Raspberry Pi. And this is what is happening on the Raspberry Pi. I have my Stream Analytics running on the Edge module, which is loaded on the Raspberry Pi.
So you basically picked the Stream Analytics module in the marketplace, added that to your configuration for IT Edge, and that's it.
That's it. That's it. The moment you are ready with your Stream Analytics job, during the process of creation of the job, it basically gives you an option whether to deploy it in the cloud or on the edge. Here in this particular case, I said, deploy it on the edge. It's the exact same language that runs both in the cloud and on the edge. That again is a big differentiator for us.
And I guess some side question is that if someone had developed an application using a previous version of Stream Analytics on their edge device and want to basically get that new functionality of machine learning in there, they just have to basically update the container, the module, and then redeploy on their existing IoT Edge device, and boom, they got anomaly detection in there.
Yes, and it is actually even more intelligent. For example, the moment you update your query, then the Stream Analytics Edge module will automatically detect that the query has been updated, and the next time you go to your IoT Edge device configuration screen, it will tell you that the code has been updated or the logic has been updated. Do you want to deploy it on the container?
Okay, that's cool.
That's good.
That's cool.
That's
very cool. I like that.
So, like I said, there is another custom Python module that is running on the Raspberry Pi, which essentially averages out the data from the Raspberry Pi being sent to the Stream Analytics module, so that rather than sending 60 seconds, 60 times every second, we only get one data point every second. And we do all the magic, all the processing on the Raspberry Pi, and just for the dashboarding purposes, so that we have a better understanding of what is happening at the device level. I have the data also being streamed to the cloud, so that we can show it in a Power BI dashboard.
That works. I like that.
So what we are using on the Raspberry Pi, as you know, Raspberry Pi comes up with comes with lots of different sensors on it. For this particular demo, we will be using an accelerometer. And accelerometer, like you see in the diagram, it has 3 different aspects to it. One is roll, pitch, and yaw. So what we are going to do in the first step is in the query. By the way, like I was mentioning, we support extensibility with C#, and to create calculate tilt from roll and pitch, we have a very complex trigonometric function. Not very easily solvable or doable in SQL. So we actually use C# UDF to actually help us calculate the tilt, and on that tilt, we will do anomaly detection.
Interesting. So what actually strikes me here is that within Stream Analytics, you're doing both data transformation and then data analytics. So you don't need to have another module in front of Stream Analytics to do the filtering or the adaptation or the transformation of your data. You can basically do that directly in Stream Analytics thanks to the UDFs.
Exactly. You're right.
Love it.
Absolutely right. So let's go into the demo. Let me pull up my Visual Studio and then show you what is happening behind the scenes. So let me very quickly take you through the query. As you can see, for any SQL query that you have written for Stream Analytics, you can just go click on add code behind, and you can write a C# routine.
This is the UDF you were mentioning, right?
Yes. And the UDF here is already defined. All I'm doing is I'm using the roll and pitch to essentially calculate tilt using the formula that I was showing before. So now we will use that tilt that we have calculated within the scope of the SQL query that we have written for Stream Analytics. So in the first part of the query, all I am doing is changing the radians into degrees. And in the second part, what I am doing is I am aggregating all the events coming into the Stream Analytics query and getting one event out every second that I want to process and calculate using the C# UDF. So in this third step, I'm just making a call to the C# UDF that I had just shown you. As you can see, I'm sending pitch and roll as arguments, and I'm getting the tilt back. The real interesting piece here is really this particular part of the query. Right? So let me go through this. I'm getting tilt, pitch, roll, and the timestamp associated with every event. And I'm calling this anomaly detection underscore spike and dip, right? The function that we went over the signature.
Only one function.
Only one function. I'm sending tilt as the parameter on which I want to run anomaly detection. Now, if you can see, I'm telling the model to flag a particular event as an anomaly only if it is at least 99.99% confident.
You want to be you want to be super sure, and you only want to have these extreme situation, right? Got it.
And then 100 is the number of events that I want the model to learn from before it actually starts scoring. Sometimes it could be 100, it could be 1,000. It really depends on the performance of your system and the kind of data distribution that you're coming. So we expect customers to do their POCs, and during the test phases really come up with these confidence level and the training count, so that they are 100% confident that the data or the anomalies that are coming out of the function are as per their expectation.
So in that case, if I understand correctly, so we're waiting, before scoring, we're waiting for 100 data points, where that's the reference, right? And then the anomaly detection, each time there's something new arriving, would actually, based on that, apply the scoring. And now when you go in time, it continues learning based on the 100 last ones, right? So in addition, right? So basically, it becomes more and more intelligent as you go, and continues basing that on these 100 previous events, plus what it was before, right? Because the model has already been trained on what it was before.
We call it a sliding window for learning and scoring. As the window is sliding, you are learning and scoring the upcoming events.
Love it. So that's the thing that's going to be interesting, because when you do demos of that and you trigger the thing and you do it too often, then the system is learning that this is no longer an anomaly because you do it that often, right?
Exactly.
So we need to be careful with demos then.
So let's see what is happening in the Power BI. I will have you help me with the demo a little bit. Not yet. So
don't touch it.
yeah. So we touched it a little bit, so you see an anomaly. So what I will let you do right now is go ahead and give it a little bit of a movement. So it could be like triggering some kind of vibration in the turbine fan.
Yep.
And you will see that within a few seconds, the anomaly will be triggered. Like you can see, the anomaly was triggered, and the tilt value actually increased. And we also expose what we call the score associated with every event. And you can see in the case of spike and dip, the score goes down, just the nature of the algorithm, whenever a particular anomaly is detected.
Okay, awesome. Nice, easy, straightforward.
Straightforward. And if you had, in a real life scenario, you would probably put like some kind of siren on it, or you can put some kind of lighting on it, so that people can be alerted immediately if there is some kind of hazardous situation.
Yeah. Definitely. So you have the alert here, on-site, offline. Awesome. So connectivity, actually, that's a question that I've been having sometimes. Machine learning is something that, in terms of billing, when you put a machine learning module on IoT Edge, requires having the IoT Edge device to actually call home base from time to time, right? To validate that you can actually run that algorithm. How does that work with Stream Analytics and ML instructions?
Yeah, so you only need the connectivity when you are deploying the code on the device. But once the code is deployed, it can completely function independently in a fully disconnected or offline environment. You don't need any connectivity to the cloud at any point.
Got it. And so you don't have an overcost for using the ML APIs within Stream Analytics. It's just Stream Analytics, basically.
Yeah, it's everything baked into Stream Analytics. That's right.
Awesome, Krishna. Love it. So if people want to learn more, I think we can send them some resources.
Yeah, so ask KSA at Microsoft.com. It is the DL for our PM team. So do ask us questions. We try to respond back within a day or two.
You realize that. You're going to be spammed.
No problem. Do it. We love it. And of course, our Twitter handle is at Azure Streaming. And all the new features that we are coming up with and all the new blogs that we are writing, we definitely make it a point to also publicize them on this Twitter handle.
Okay. People, you know what you have to do. Follow at Azure Streaming. Also follow the IoT show if you have not subscribed yet. Thanks a lot, Krishna. Great demos, great topic. And guys, go knock yourself out with machine learning on Stream Analytics.
Thank you.